Hi everyone, my name is Rebecca Duke and I work for the Science and Technology Facilities Council at the Hartree Centre. I'm a data scientist and this means I help businesses use the data that they've got to make better decisions. Today we're going to talk about AI, artificial intelligence, and we're going to use nursery rhymes to understand how generative AI programs work. The first question is, what is artificial intelligence? Does anyone have any ideas? AI is seeing patterns in data using a computer algorithm. It's often used for predicting what could happen, and at the moment it's usually built to do a specific task. Doctors use artificial intelligence to identify illnesses on medical scans, and computer games use artificial intelligence to control what is happening as you play. What AI is not is cyborgs. Well, at least not yet. Here's a second question. Has anyone here used AI? I think that everyone watching, either you or your family members, will have used AI, maybe without really realizing that you're using it. So if your parents have used a map tool to work out the best way to get somewhere, that will be powered by AI. If you've talked to a smart speaker or other device and asked it to play you a song or tell you a joke, that is using AI. And if you've watched a video on a streaming service and it's suggested other videos that you might like to watch, that suggestion is also powered by AI. Today, I'm going to talk very specifically about generative AI. Generative AI is what we call AI that makes or generates things. These can draw you a picture, or you can talk to them by typing questions. You might have used ChatGPT, or Microsoft Copilot, or Meta AI versus WhatsApp. Generative AI will tell you a joke. It can write you a recipe. It can suggest where you should go on holiday. In many situations, it's a really useful tool. But how does it actually work? Well, together we're going to create the great nursery rhyme generator. What we're going to do is build our very own generative AI using nursery rhyme text. And by doing so, we'll understand how generative AI works underneath the hood. The first thing you need to build your own generative AI is get a whole lot of data. What I've done is I've collected 50 nursery rhymes and I put all the words of them together. You can see some of their first verses here. In order to understand all of the words that appear in my nursery rhyme collection, I'm using a word cloud, which is a way of visualizing text data. The bigger the word, the more times it appears in the document. So takes, put, see, and way are the most common words in the nursery rhymes I'm using. But if you look at some of the smaller words that appear less often, you'll start to see people you recognise. Old MacDonald, the Muffin Man, Goldilocks, and you can start to guess which nursery rhymes I've used. This way of visualizing words shows us which words are most common. What our generative AI system needs to do is work out which word should come next. And the easiest way of doing this is for each word, find the word which comes next most often. In maths, you might have heard about the different types of ways of summarizing groups of data. The most common one is the mean, which is what most people mean when they use the words the average. However, today we're using a different type of averaging, which we call the mode. And if you choose the mode, you choose the most popular word or item in a group. So what we're going to do in our first version of a generative AI program is, given a start word, we look at all the words that appear next in our data, and we pick the one that appears the most, the biggest one in the word cloud. So I'm going to start my program with the words, little Bo-Peep has lost her. What we do then is we create the word cloud for every word that comes straight after her in our data. As you can see here, most of the time, the word that follows her in a nursery rhyme is mother. This comes from an American nursery rhyme called Billy Boy. So we pick the word mother and then look for all the words that follow mother. For that, there is only duck, which appears 4 times, and vexed, which appears only once. So we end up with as a phrase with little Bo-Peep has lost her mother duck. We can see our path here. We started with little Bo-Peep has lost her, then we picked the most common next word, which is mother, and then we picked the most common word that comes after mother, which is duck. So we've generated our first sentence. However, the trouble with using the mode, we get exactly the same options every time because we always choose the most popular. It sounds quite a lot like a nursery rhyme, but it would be really boring if every nursery rhyme started the same way. It would be the same as your English teachers telling you to use other words instead of said when you're doing creative writing to make your writing sound more interesting. We need to make our generative AI output more interesting. What we're going to do is add a little bit of randomness, and that randomness allows us to vary the words that we're generating next. Randomness means natural chance, and we see it when we roll a dice or flip a coin. We know the set of possible things that could happen. On a dice, it could be anywhere between the numbers 1 and 6. But we don't know when we roll a dice which of those numbers is going to come up. So to add randomness to our generative AI, I'm going to take the set of all the possible words that follow her in our data, and I've written them all on a piece of paper according to the number of times they appear in the list. So in my box of words, mother is there 5 times because that's the most popular, and fingers is in there only once. So what I can do is I can pull a piece of paper from my box to be my random selection. So little Bo-Peep has lost her chin, or little Bo-Peep has lost her 2. This way we get a different set of words every time we run the algorithm. And we end up with little Bo-Peep has lost her mother duck. Or we can have little Bo-Peep has lost her web, right? Or little Bo-Peep has lost her to come. Some of these sentences make sense, and some of them don't make that much sense, because the algorithm that we've got so far doesn't understand grammar and the rules of English. But at least we're getting a little bit more variation in our output. So we started using the mode. We got a very boring but reasonably sensible output. And then we added randomness. And we got some more interesting variations, but not all of them make much sense. So in order for the algorithms to start to learn the more complicated rules that underlie English, we need to start to include techniques from artificial intelligence. And the technique that we're going to use is called a neural network. A neural network is a kind of algorithm that works by copying the way our brains work. If you scanned your brain, you would see a whole load of brain cells. We call them neurons, and they take information in, and each brain cell then responds or it doesn't respond. That response goes into other neurons as they're all in a big connected web. And these further neurons, again, take in a lot of information and respond or don't respond. Neurons themselves are very simple. Each one says yes or no. But by connecting lots of them together, our brains help us learn to do all sorts of amazingly complicated things. We learn to walk and read and jump and play games simply by having a load of neurons that are each saying yes or no. When we're building AI, we copy that same structure. The first thing we need is data to teach our network. Lots and lots of data. The more data you have, the better the neural network you'll build. We're still going to use our 50 nursery rhymes, but really we should be using thousands of pages of text to make a really well-trained network. And then we're going to create our structure. We're going to mimic our brain. In our simple diagram here, each of these circles we called a node, and they are the neurons in our AI brain. They each make a decision based on the inputs from the previous node, and they pass that decision forward to the next layer. Like a human brain, you can have lots of them all connected in different layers to make a really complicated structure, but this picture shows you a very simple version. What happens when we train our neural network is we feed the data in one by one, and for every new example, each of those nodes will say yes or no. These messages pass through the layers until they get to the final node, where you get your decision. In our case, you'll get a word out, which the neural network thinks should be the next best word. When you first put data into a neural network and it's not yet trained, it guesses almost randomly, so it doesn't get it right very often. But after the network has given an output, the way the algorithm works is we pass back the correct answer. And this tells every node whether it was right or wrong. And by using this information, each node changes its answer a little bit to make it more correct. We pass our data through lots and lots of times. And by doing this, the network learns the patterns in the data and gives the right answer more times. But it's not learning in the same way that you would learn in school. No one's teaching it that this is a noun and this is an adjective, and adjectives are used next to nouns to describe them. It's learning the way the structure of the English language works just by seeing these patterns in the data lots of times without any other information. For our nursery rhyme generator, I've trained a particular type of neural network called a long short-term memory, LSTM network. And the other thing that introduced by using this network is I've allowed us to move from looking at only one word and the immediate word that comes next to looking at groups of words and what comes next from the whole group of words. So to train this neural network, I've passed the data that I've got through 300 times to try and get a good performance. Every time you pass the data through, you can see how often the network got the next word right. And you can see in the beginning view that the accuracy, how many we got right, starts at 12 or 13%. But by the time we've passed the data through 300 times, we're up to 80 or 90%, as the network has got better at learning the information we've passed through. On the right-hand side, we've fed in the red words to start the sentence, and the neural network has filled in the other words. It might look like it makes less sense, but actually you can see that the network is learning some of the structure you expect in a nursery rhyme. Little Bo-Peep, in, hill, away the lamb, 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 Mary. Doesn't sound like good English, but actually if you look at nursery rhymes, they often repeat words multiple times. So it's learnt that structure of nursery rhymes. Plus, almost everyone's called Mary in a nursery rhyme. Little Bo-Peep has lost in hill dilly. Another interesting part of nursery rhymes is that they often rhyme, hence nursery rhymes. And so it's introducing hill and dilly coming next to each other because they rhyme. Little Bo-Peep has lost her sheep, little whip lamb not know where to find them. Again, it doesn't sound normal English, but for the first time, it's introduced the word lamb after we've seen sheep earlier in the sentence. And so it's connecting the similar words over a longer time period. However, it's still not brilliant, is it really? Part of the problem is we've not really fed enough data into our nursery rhyme generator. 50 might sound like a lot, but it's actually really a small number when it comes to artificial intelligence. And the generative AI models that you can use on the internet have been fed the whole of the internet. And the more data you can feed into your artificial intelligence, the more the models can learn behaviors and relationships in the data. So that's one part of our problem, not enough data. And then the other part is I've used a relatively simple network structure to make it easier to train, whereas the top level of generative AI use very complicated network structures. So let's see what we could get from ChatGPT, which is possibly one of the most common generative AI interfaces that people use. I gave it the prompt, write a new nursery rhyme that starts with Little Bo-Peep. It replies, sure, here's a new twist on the classic nursery rhyme. Little Bo-Peep, with her hat so neat, went out for a stroll on a warm, sunny street. She met a small rabbit as white as the snow, and they danced in the meadow where wildflowers grow. Little Bo-Peep, with a singing a song, skipping a song, sang to the birds as they flew along. Come play with me, oh come and see the magic of nature, so wild and free. Little Bo-Peep, with a twirl and a cheer, found her lost lambs, they were never too far. With a smile on her face and a heart full of glee, she knew that the world was the best place to be. Now, compared to our first attempts, that is much more sophisticated, and it's a much closer mimic of nursery rhymes that you would see. It's still not the best, and I would argue that it's not as good as might be written at the moment by a human. Some of those rhymes are a little bit dodgy. Cheer and far don't really rhyme, but it's getting really close to the level of nursery rhymes you would expect to hear. So let's look at the evolution of what we've done. We started simply by using the mode, the most common next word. And we got something that sounds a bit like a nursery rhyme, but you can very much see where each step of the rhyme has come from. 5 little ducks went swimming and got mixed up with Little Bo-Peep. We added some randomness. And that way we get something that still makes sense. Little Bo-Peep has lost her 2 eyes. But not all of the options that we generated randomly made sense. And that line is a little bit on the creepy side. Then we started to train an AI algorithm. We got something that, on the face of it, looks actually to make less sense than the previous 2, but it actually captures a lot more of the way that nursery rhymes are structured, with their repeated words and with their rhymes. And so it's recreating the structure. Rather than kind of taking words from previous nursery rhymes, it's actually giving us more newness, but within a better understood structure. And then finally, we went to the cutting edge and we used ChatGPT. And this gives us a much more complete nursery rhyme. It makes sense. It's a lot longer. It's got better structure. It's a lot closer to what you would expect. So what we see here is as we add more complicated approaches, we add randomness, and if we add a whole load more data, we can train a computer algorithm to write something that actually you might not guess wasn't written by a person. Now I know what some of you are thinking. Nursery rhymes, a bit boring, a bit babyish. So why am I using a nursery rhyme as an example to you? Why haven't I generated a pop song based on my favourite artist? Well, the problem with creative media, like pop songs or stories or art, is that they belong to the people who wrote them or made them or drew them. And one of the problems with generative AI models is that they're trained on everything on the internet, but they don't always have permission to use that information. They've taken someone's idea without asking. And there are many people who are arguing that generative AI companies have stolen their ideas. These discussions are going through the law courts for judges to decide at the moment. So now we've talked about how generative AI systems work, and we've learned some of the steps in the way they've made them more successful at mimicking human speech. But what about if you want to go away and use these tools? Using these tools is great as long as you remember that that's all they are. They are tools to help you rather than tools to replace you having to put any effort in. There are some situations where they're really helpful. If you want them to suggest what to get your dad for his birthday, they might come up with some really good presents that you've not thought about. If you want to work out where to go on holiday and get some restaurant recommendations, that's great as well. If you want a generative AI to give you an idea for a story to write or a picture that you can go away and draw, amazing. However, there are a few things that you need to be careful of if you're using these tools. Firstly, generative AI can do what we call hallucinate. It can make things up. It's generating words based on the next word that's most likely to appear, based on the data it's seen on the past, not because it knows the truth. So if you're asking it any particular fact, you might want to double check it's got them right before you use them. Secondly, generative AI can be biased. Biased is when an algorithm is learnt from the data it's seen, but if it hasn't seen a fully complete set of data, it might not give fair answers for everyone. Almost half of the internet is written in English, so generative AI models work better when you're talking to them in English than they do in other languages, which means that they don't represent different people's worldview. Thirdly, generative AI has a particular way of putting words together. If you're using it for your homework, your teachers can tell that you've used it because it doesn't sound like all the other work you do in class. One other thing to think about is actually the energy usage of generative AI. Not only does training these complicated models take a lot of energy, which is bad for the environment, but every question you ask uses about 5 times more energy than a search engine. So if you want to know something that is well known or easy to search, then you're better off using a search engine than you are asking generative AI. Hopefully, you now understand a bit of how generative AI works, including some of the statistical techniques that power it, and you're aware of things you need to be careful about if you're using it. Thank you for listening.